Physics is not a list of rules that some old guys wrote down and decided to enforce on the universe. That's a common misconception, and it's actually funny when you think about it. Physics is the description, the best description we have of how nature actually behaves. It's not a law that nature obeys. It's our description of what nature does. And here's the beautiful part. These descriptions work everywhere. They work in my lab at Caltech. They work in Tokyo. They work in the deepest space we can observe, and they work on the smallest scales we can measure, down through about 43 orders of magnitude. That's incredible. So when someone says aliens might have beaten physics, what they're really saying is aliens might have beaten the way the universe works. And that's just incoherent. You see, there's something that people don't understand about the universe. There's something called the laws of conservation, conservation of energy, conservation of momentum, conservation of charge. Now, these aren't arbitrary. They come from something much deeper, from symmetry, and symmetry is everywhere. Let me think about this differently. Imagine you're an alien. You've got 10 billion years of technology. You're incredibly smart, way smarter than us. You've built things we can't imagine. Now let me ask you a question. Can you build a machine that creates energy from nothing? Can you invent a technology that violates the conservation of energy? The answer is no, not because you're not smart enough, not because you haven't had enough time, but because it's impossible in the way the universe is constructed. The universe doesn't allow it. Energy can be transformed. It can become heat or light or kinetic energy or potential energy. But the total amount of energy in a closed system never changes. This isn't something physicists wrote down and the universe decided to follow. This is something physicists observed about the universe and wrote down in a mathematical form, and it applies everywhere. Now let me take this further. Consider the second law of thermodynamics. This one is interesting because it's a bit different from the conservation laws. It says that in any real process, the total entropy of a closed system never decreases. Entropy is a measure of disorder, roughly speaking. And what this law is really saying is that the universe has a direction. The past is different from the future. Eggs break but don't reassemble. Heat flows from hot to cold but not the other way. And here's the thing. This law applies to everything, including to aliens. Now, some of you might say, well, maybe an advanced civilization could use quantum mechanics or some physics we haven't discovered yet to get around these laws. And I understand why you'd think that. But you have to understand what quantum mechanics actually says. Quantum mechanics doesn't break the conservation laws. It doesn't violate entropy. It just works on a smaller scale. An electron tunneling through a barrier still conserves energy. It just uses the strange probability rules of quantum mechanics. But the laws themselves, the fundamental symmetries, those are still there. And let me tell you something that people find remarkable when they really think about it. The laws of physics that we've discovered, the ones we write down in our textbooks and use to build our technology, these laws seem to be the same everywhere in the universe. We can see this from astronomy, we can see the light from distant galaxies, and we can analyze that light and determine what elements are in those stars. We can test whether the same physics that works here in our lab works in a star that's billions of light years away. And it does, the same physics, every single time. Now, this doesn't mean we know all the physics. We don't. We know that there are mysteries. We know that at the very smallest scales in the quantum world and at the very largest scales with gravity and the expanding universe, there are things we don't fully understand. Quantum mechanics and general relativity don't quite fit together properly, and there might be other laws we haven't discovered. But, and this is crucial, those undiscovered laws are not going to allow you to violate conservation of energy or create a perpetual motion machine or beat the fundamental symmetries of nature. Why? Because those symmetries come from something deeper. They come from the mathematical structure of space and time itself. And that's not something that any amount of technology can get around. Let me talk about thermodynamics again because this is crucial for understanding alien technology. Suppose the aliens have gotten around conservation of energy somehow, which they haven't, but suppose they had. They could still build a spaceship and fly it between the stars. But how much energy would it take? Well, as you accelerate a spaceship to higher and higher speeds, closer and closer to the speed of light, the amount of energy you need increases without limit. It approaches infinity. This is not a technological limitation. This is a mathematical property of space-time itself. It comes directly from Einstein's theory of relativity. And here's something interesting. There's no way around the speed of light that we know of. And I want to be careful here. I'm not saying there's no way that will ever be discovered. Science progresses. But here's what I'm saying. We have a principle. And it's not a law that some physicist wrote down. It's a property of space-time. If you try to accelerate any object with mass to the speed of light, you need infinite energy. That's built into the mathematics of the universe. Now, is there some physics we haven't discovered that might change this? Maybe. But it would have to be so different from everything we know that it would be surprising. Very surprising. And even if somehow there were ways to get around the speed of light, and I'm not saying there are, but even if, that wouldn't be beating physics. That would be using different physics that we haven't discovered yet. But those physics would still have to be consistent with what we do know. They'd have to be consistent with observation and experimentation. Here's what I want you to really understand. When we say something is impossible according to physics, we don't mean it's difficult or that we haven't invented the right technology yet. We mean it's inconsistent with the fundamental mathematical structure of the universe as we understand it. There's a difference between we don't know how to do it and it's impossible in principle. Now let me ask you about your intuitions. People often imagine that aliens might be able to do things that seem impossible to us. They might be able to manipulate gravity or create wormholes or travel through time. These are great science fiction ideas, and I'm not saying that some of these things are impossible, but let me tell you what we know. For gravity, well, gravity is actually not a force in the way Newton thought of it. It's the curvature of space-time itself. If you want to manipulate gravity significantly, you'd need to control vast amounts of mass and energy. The physicist Miguel Alcubierre did some calculations about whether you could create a warp drive that would let you travel faster than light. And technically his mathematics works, but it requires something called negative energy density. We've never seen this. We don't even know if it can exist in the quantities needed. And even if it could, controlling it would require more energy than we know how to generate. Wormholes? Similar story. The mathematics of general relativity allows for solutions that look like wormholes, shortcuts through space, but they're unstable. They'd collapse. And again, you'd need exotic matter that we've never observed. And time travel, going backward in time, this is where the physics gets really subtle. And I'll be honest with you, physicists disagree about some of this, but here's what we know. Every solution in general relativity that allows for time travel backward in time has some problem. Either it requires exotic matter or it leads to causality violations, situations where you can create paradoxes. And the universe seems to avoid these. So far, we see no evidence that backward time travel is possible. It might be that the laws of physics simply don't allow it. But notice what I'm saying. All of this comes from physics. It's not that technology can't do these things. It's that the physics of the universe might not allow them. And that's a crucial distinction. Now, let me talk about something that people don't often think about. There's a scientist named Nikolai Kardashev who came up with a way to classify civilizations by how much energy they can use. A type 1 civilization would use all the energy falling on their planet from their star. A type 2 civilization would use the energy of an entire star. A type 3 would use the energy of an entire galaxy. Now, the Kardashev scale is interesting because it helps us think about technological advancement. But you know what's interesting? Kardashev himself said that even these super advanced civilizations would still be bound by the laws of physics. They'd have to obey conservation of energy. They'd have to deal with thermodynamics. They couldn't violate the fundamental symmetries. And here's where it gets interesting. There's a thought experiment that some physicists have done. They ask, what if a civilization becomes so advanced that it can change the laws of physics? And the answer physicists give is, well, even if that were possible, it wouldn't break the laws of physics. It would just be revealing that those laws are not the true fundamental laws. There's something deeper underneath. And whatever that deeper level is, you can't break the laws at that level by definition. You see, it's a bit like asking, can you do something that violates the laws of logic? The answer is no, because if you violate the laws of logic, you're not actually doing anything coherent. It doesn't mean anything. So let me bring this all together. Can alien technology beat physics? Well, I need to clarify what that question means. If it means, can aliens do things we can't do? Then the answer is probably yes. They might be able to do wonderful things, but if the question is, can aliens violate the fundamental laws of nature? Then the answer is no, they cannot. Not because they're not smart enough, but because those laws are not arbitrary. They're built into the structure of the universe itself. Now, I want to tell you something about physics that I think is important. Physics is not about prediction. Well, it is, but that's not the essence of it. The essence of physics is understanding. It's asking why about the natural world. And when we ask why persistently, when we keep asking why to each answer, we eventually reach a level where we find patterns, symmetries, conservation laws, mathematical relationships, and these patterns hold everywhere we look. They hold in the laboratory, they hold in the stars, they hold in galaxies billions of light years away. This is what's remarkable about physics. Not that physicists are clever, though some of them are, but that nature itself is so astonishingly clever that the universe has constructed itself according to such elegant principles. Now, let me talk about something specific that people often ask about aliens. People say, what about anti-gravity? Can aliens make technology that negates gravity? Well, let me tell you about gravity. Gravity is not like an electric field where you can have positive and negative charges and they can cancel each other out. Gravity is the curvature of space-time caused by the presence of mass and energy. You can't have negative mass, or can you? Theoretically, general relativity allows for exotic forms of matter with negative energy density, but we've never observed this, we've never created it. And the amount of energy it would require to create enough of it for a spaceship to use would be astronomical. More importantly, here's what's interesting. If you tried to create negative energy and use it for anti-gravity, you'd still have to obey thermodynamics. You'd still have to obey conservation of energy and momentum. The process of creating and controlling this exotic matter would generate entropy. It would produce heat. You couldn't have a perfectly efficient system. And that's the thing about the laws of physics. They're not separate rules that you can break one at a time. They're all connected. They all flow from the same deep principles. You can't violate conservation of energy without also violating conservation of momentum. You can't create energy from nothing without violating the second law of thermodynamics. Let me give you another example. Suppose aliens figured out how to access parallel universes or other dimensions. Suppose they could reach into higher dimensions and pull energy from there. Wouldn't that let them have unlimited energy? Well, first, we have no evidence that other accessible dimensions exist. String theory suggests they might, but that's very speculative. But even if they did exist, here's the thing. If you can access another universe and extract energy from it, you're not actually escaping the laws of thermodynamics. You're just expanding the universe you're considering. When you include that other universe in your calculation, conservation of energy still holds. The total energy is still conserved. This is what I mean by the universality of physical laws. They're universal. They don't just apply locally, they apply to the whole system. Now I want to address something that a lot of people think about with aliens. They think about UFOs, about flying saucers that seem to move in ways that shouldn't be possible. They hover, they make right-angle turns at high speed, and people say, well, that couldn't be done with our physics, so it must be alien. But you see, there's a logical problem here. Let me think about it carefully. If I see something happen and I think it violates the laws of physics, there are a few possibilities. One, I'm wrong about what I'm seeing. Our eyes and memories are not as reliable as we think. Two, I'm not understanding the situation correctly. Maybe there's a force or effect I'm not accounting for. Three, our understanding of physics is incomplete or wrong. Now, the last possibility is always open. Physics might need to be revised. But here's the thing. That doesn't mean the laws of physics are wrong. It means our current understanding is incomplete. And any new physics would have to be consistent with the observations we've already made. It would have to reduce to our current physics in the limit where we've done our experiments. So if aliens are real and if they have technology, that technology has to work with the laws of physics, not against them. It might use physics that we haven't discovered yet, but it has to be consistent with observation and logic. Actually, let me tell you something interesting that a physicist named Richard Feynman, well, that's me. And I understand the irony of saying that. Something I said was, what I cannot create, I do not understand. And the inverse is true. If I truly understand something, I should be able to create it. I should be able to make something that embodies that understanding. Now, what this means for technology is this. If an alien civilization truly understands physics, the deep physics of the universe, they can use it to create technology. But that technology is still constrained by those physical laws. They can't create a perpetual motion machine because perpetual motion machines are impossible. They can't violate conservation of energy because energy is conserved in every process we've observed. But here's what's really interesting. What they can do might seem like magic to us. They might have technology that's so advanced that works according to principles we haven't discovered yet that we couldn't even recognize it as technology. Arthur C. Clarke, the science fiction writer, said something I like. Any sufficiently advanced technology is indistinguishable from magic. And I think that's true. But that doesn't mean it's violating physics. It just means we don't understand the physics it's using yet. Now let me talk about the implications of all this. If alien technology can't beat physics, what does that tell us about the universe? Well, it tells us something important. The universe is not a playground where anything is possible. There are limits, there are constraints, and those constraints come from the deep mathematical structure of reality itself. This is actually a hopeful thing, in a way. It means that the universe is rational. It means that we can understand it through reason and experimentation. It means that what an alien civilization discovers about the laws of physics should be the same as what we discover, because the laws are the same everywhere. And here's something that not many people think about. If the laws of physics are truly universal, and if those laws severely limit what kind of technology is possible, then maybe alien civilizations have hit the same technological barriers that we'll eventually hit. Maybe the reason we haven't found any aliens out there is not because they don't exist, but because technology hits a ceiling. Because at some point, further advancement is impossible, not because you're not smart enough, but because the laws of physics don't permit it. There's an idea called the universal limit to technological development. The idea is that civilizations might not be able to advance indefinitely. They might hit a point where to make the next big discovery requires so much energy, so much experimentation, so much infrastructure, that it becomes impossible. And when every civilization in the universe hits that same limit, well, then you have a quiet universe. You have no technological civilizations out there. And maybe that's why the universe is so quiet. Now, I find that fascinating because it suggests that the laws of physics are not just describing what happens, they're actually determining what can happen. They're the boundaries of possibility. So, to answer the original question, why can't alien technology beat physics? The answer is because physics is not something that can be beaten. Physics is the description of how the universe works, and that description is the same everywhere, for everyone, no matter how advanced they are. Aliens might discover new physics. They might find that our current understanding is incomplete, but they can't beat the fundamental laws. Those laws would still be there, still constraining what's possible, still beautiful in their simplicity and universality. And you know, I think that's actually more impressive than the idea of aliens with unlimited power. I think it's more remarkable that the universe is constructed according to such elegant principles that even the most advanced civilization in the galaxy can't escape them. The laws of physics are not chains that hold us back. They're the expression of how nature works, and understanding them is understanding reality. That's what I find beautiful about physics. Not that it tells us we can do anything we want, but that it tells us exactly what's possible and what's impossible, and the reasoning behind it is so elegant, so mathematically simple, that you can look at it and see how clever nature is. Not how clever we are, but how clever nature is to pay attention to these laws. So the Feynman verdict is this: alien technology cannot beat physics, not because the technology isn't good enough, but because physics is that good. And that's actually something to be in awe of.